Okay, this lesson is one of those random lessons that we sometimes throw in before we get to our EOC because it covers something that you might see on your final exam. It's not a difficult concept, but it is something that you need to have explained to you or you won't know what you're looking at. So I'm going to put 3 expressions up on the screen here, and you're probably going to look at them and say, I have no idea what that is. And by the end of this lesson, you're going to know what it is and know what to do with it. So it looks something like this. And then we'll have that and okay, and it might look something like that. And you might be, if you saw something like this, the directions would say evaluate. And remember, the word evaluate means find the numerical value. Okay, usually by plugging in numbers. You plug in numbers and then you evaluate. Now, you might see something like this. So we'll throw in, we'll do a K. I know 5. Oh, whoops. I hate it when I do that. Okay, and then the last one, I used an I. You actually will see an I for these. It's not super common, but it's not the imaginary number, just so you know. It is being used as a variable in this case. So you might look at this and say, I have no idea where you're going with that or what you're supposed to do with it. And the purpose of this lesson is just to explain what it is, what you do with this notation, what you're expected to do. And then I would like to at least show you where you might see this notation other than in a lesson on this notation. So let's talk about this big, this big thing. Okay, now that's how I draw this symbol. If you were to see it printed out, it would look something like this. Okay, it would look a little bit more like that. You might see something like that. Okay, it might look like that. I've seen like college professors just do that. Okay, so it can get a little bit messy. Sometimes you'll see like the little tabs put on the end, like a little bit more like that. And that's kind of what I'm doing with that. I'm trying to put the like little tabs on the end. It's not a really easy symbol to make. And so depending on whether you're seeing it handwritten out or you're seeing it typed out, I just want you to know that that's what you're looking at. So if you've seen similar things. Now, what on earth is that symbol? That is a capital sigma. Okay, not to be confused with a lowercase sigma, which is that symbol there. Okay, that is a capital sigma. It's a Greek letter, so where you might have heard Greek letters, sometimes honor societies are named after Greek letters. I belong to an honor society called Phi Delta Lambda, which is from the college that I went to. Sororities and fraternities are often named by Greek letters, and we use them in math and we use them in science as well. So that symbol there is a capital sigma, and here's what it means. It means to sum, and of course, sum means add up. So when you see that symbol, it's a way of writing usually repeated addition. So if you have like a bunch of numbers that you need to add up, but you don't want to keep writing plus all over, like over and over and over again, you can use this symbol as a shorthand for adding things up. Now, you'll notice that there were some things in addition to that symbol. So you've got a variable, and that variable, whatever you see as the variable down here, is also in an expression up here. So we have like the I, we have the K, we have the N. This maybe should be in parentheses. That might be a little debatable there. Okay, and so you see a variable down here, and then you see an expression with a variable in it, and then you'll see a number and then a bigger number. Okay, so there's like a smaller number at the bottom, in this case a 1 and then a 3, or a 0 and then a 5, in this case a 1 and then a 12. Oh, so help us, that's kind of a nasty one. Okay, and so what you're looking at there is what's called a lower bound or a lower number. It indicates the smallest number that the variable could be, and then you have what's called the upper bound or the upper value, and that would be the highest number. And it is implied that you will count up with integers, okay? So you're never going to deal with like 1.5. So in this expression here, the lowest that n can be is 1. The biggest that n can be is 3. And so if you count by integers, that means n could be 1, n could be 2, or n could be 3. In this one, the smallest value that k could be is 0. The biggest that k could be is 5. So if you count up by integers, you could have 0, 1, 2, 3, 4, or 5. And then the same deal here. The smallest that I can be is 1, and the biggest that I can be is 12. So I could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12, and I might just break into a Sesame Street song from the 1980s, but I'll spare you that. So what are you supposed to do with it? What you're supposed to do is you're supposed to take the smallest value for n, plug it in, then take the next value, plug it in, take the next value until you get to the top one and add them all up. So now that I've explained it and we've gone over what all the pieces are, pretty much the best thing to do is to see an example. So what does that look like when you go to do it out? And there's no one, I don't know why that didn't, right? There we go. Way to structure the work for this, but you do want it to be clear what you're doing. So we'll start off with this one. I don't know why my iPad is not. Okay. So the smallest n could be is 1. Then n could be 2. Now notice the 4 stays the same. Okay, so it's like 4n. So you could have 4 times 1 and, all right, I like that better. So that's equal to 4 times 1, 4 times 2. Then you're going to count to 4 times 3, and then you stop because you just hit the top. And what do you do with all that? You add them up because that's what the symbol means to do. And so we have 4 plus 8 plus 12, and 8 plus 12 is 20, and 20 plus 4 is 24. And so if you are asked to evaluate, remember evaluate means find the numerical value of, then the numerical value of that first expression is 24. And that's how you do it. It's not difficult, but again, somebody does have to show you what it means. It's not something that you just look at and say, oh yeah, like that's obvious what you're supposed to do. It's also something that you need to practice a couple times, just because it can be a little bit awkward. Let's look at the second one there. We have our sigma. The expression here is k squared, and k can be anything from 0 up to 5. And so what would that be equal to? Well, we have k could be 0. So you have 0 squared. After 0 comes the 1. So you have 1 squared. Then you have 2. Then 3. Then 4. And then 5. And then that's where you stop because that's your upper bound, and we're going to add all of these together. Notice that the squared stays the same. It's the k value that is changing. And so 0 squared is 0, plus 1, plus 4, plus 9, plus 16, plus 25. And then we're supposed to add all this up. So what do we have here? We have 1 plus 9 is 10. 4 plus 16 is 20. So 20 plus 10 is 30. And 30 plus 25 is 55. And so the numerical value of this one is 55. And then the last one. We won't do the whole of the last one out because you can probably tell now, like, oh, that's not going to be fun at all. So this was I is equal to 1 to 12. Awesome. Of 2i plus 3. Okay, and so we would have 2 times 1 plus 3. There's the first one. Then we have 2 times 2 plus 3. Then we have, and you know what might be, what you can do too, if it helps. Sometimes some students prefer to arrange them this way so that you can see the the variable value changing. So you're not going to change the 2. You're not changing the 3. The only thing that's changing in there is the variable. In this case, the I. Okay, and I'm only halfway done with that. So that's going to go all the way up to 2 times 12 plus 3. And what you would notice is that there's a pattern to these numbers. This is a linear function because it takes the form mx plus b. And so these numbers, if we were to find what they all were, we would notice a pattern. So this is 5, 7, 9. Oh, these are odd numbers. Beginning with 5, that's what the plus 3 does. So pretty much this is adding up all the odd numbers from 5 to 27. And so then you would grab your calculator and you would add them all up. So that's what the notation is. So you would see this in a branch of math that deals with sequences and series, which sometimes we get to in Algebra 2, but a lot of times we don't get to it. It's one of those things that you could cover it in Algebra 2, but you could also cover it in a pre-calculus class, so there's not a lot of pressure for us to do it. But it's when you deal with numbers, like patterns of numbers, rows of numbers, and you want to add them all up. Now you might be thinking, well, seems like a lot of work. Is there a faster way to do it? Yes, there is. So there are some formulas that you could learn or memorize that would help you take some shortcuts with this. And of course, those formulas take some developing. And so, we're not going to do it in this lesson because this lesson is just about what that notation is. This also comes into play if, for those of you that eventually go to calculus, you add up a bunch of areas. So you do something like this, where you take a curve and you want to find the area of the curve. So you're probably thinking, but what if I don't want to find the area in the curve? Trust me, you do. There's all kinds of really interesting things that are modeled by the area. But what you would do is you would find each of those areas of those rectangles and you would add them up. And so there would be a pattern to the areas of the rectangles that would be correspond to the function, like whatever function that is that looks a little bit like a sine wave or whatever. And you would add them all up, and you just have to take my word for it. There's some really cool stuff that you can do with it. So another place where you might see that symbol is if you were finding the average of numbers. So when you're finding the average, so let's say I wanted to find the average of 2, 4, 1, 3, and 7. Okay. I would do 2 plus 4 plus 1 plus 3 plus 7, and I would divide that by 5. Okay. That right here is that I'm circling there. That's a summation. And so sometimes when you see the formula for average, you'll see it written this way. You'll see average, which is sometimes written with a bar over it. It's read X bar. And then you'll see something like that. Okay, where you would, and what that means is add up all the values and then divide by however many values there are. And so you'll see this notation pop up in places, and I don't want you to freak out. It just means to add them up. So the best way to figure out how well you understand it is to actually try a problem on your own. So I'm going to put a problem on the screen here, and then we'll pause and I'll give you a chance to work it out. So we're going to start this at 5, if I can put the top on the 5 there, and we're going to stop it at 9. I have 10 in my notes, but just for our sanity, that's a 9. Okay, because none of us want to do too much with this. And then I'm actually going to change this. I'm going to do, no, I can't. Just kidding. I'm going to give you 2 problems to do instead. We'll do j squared plus 1. And then for the second problem, we're going to do this. We're going to do n is 0 to 3 of 2 to the n. So we're going to put it into the exponent and make that an exponential function. So pause the video and try to work those out on your own, and then we'll resume and you can see how you did. All right, for this first one, your work should look something like this. Your first number is going to be 5 squared plus 1. And then you're going to count up from there. So you're going to have 6 squared plus 1, 7 squared plus 1, 8 squared plus 1, 9 squared plus 1, and that's where you stop because you've hit your upper bound. Now, when you do these out, you should see a pattern to the numbers, and I was actually poking around, like looking for the pattern. And it is there because this is not random or haphazard. This is a quadratic of some sort because because of the j squared. And so you know that there is a pattern to the numbers. Sometimes seeing the pattern, it would be easier to see it if you graphed it as opposed to just numerical. But the first number here is 25 plus 1, which is 26. Then 36 plus 1, which is 37. 49 plus 1, which is 50. 64 plus 1, which is 65, and then 81 plus 1, which is 82. Now, just so you can see what the pattern is there, to get from here to here, I hate when that happens, you're adding 11. To get from here to here, you're adding 13. From here to here is adding 15, and from here to here is adding 17. And so you're adding the next consecutive odd number each time you move to the next one. So the pattern isn't super easy to see, but it is there. And then remember that the summation notation does mean to add. And so we're going to add that column up. What do we have? We have 13 plus 2 is 15, and 15 plus 5 is 20. And then what on earth is this? We have 4 plus 6 is 10. Plus 11 is 21, plus 5 is 26. And so for that one, you should have 260 as your answer. Okay, for this one, we have 2 to the 0, 2 to the 1, 2 to the 2, 2 squared, and 2 to the third, and that is where we stop. The reason I had to change that before is because like these numbers get really big. I mean, we've done enough with these numbers to know that they get really big really fast. And so we don't want to deal with like even a 2. We don't want to deal with like 2 to the 9th power. It's a little much. All right, so 2 to the first power, 2 to the 0 power is 1. 2 to the first power is 2. 2 squared is 4, 2 cubed is 8. And what you should notice is that you're multiplying by 2 each time. This is something called a geometric sequence when you multiply by 2 each time. And then when you add them up, becomes something called a geometric series. And there are a couple of formulas for finding the sum of geometric series. In fact, you can get into like what are called convergent and divergent series. And converge means that you can add an infinite number of numbers in, and it actually will approach a limit. Divergent means it just kind of keeps going forever. 2 plus 8 is 10, plus 5 is 15. And so for this one, you should have an answer of 15. So that's it for this lesson. And again, the goal of this lesson was just to kind of toss in what summation notation is so that should you see it on your final or in the future or on an SAT or whatever else might, get tossed your way, that you would know what the symbol was and what it intended for you to do. And that's a wrap.